Okay, hi everyone. In this video, I would like to discuss subtopic 7.7, Doppler effect. So this is the last subtopic for this chapter. Okay, so Doppler effect is basically when you hear frequency that is not the actual frequency due to the motion of the source or the object. Okay, so here you have only one formula. This is the formula for the Doppler effect. Okay, you have FA that represents apparent frequency. This one like olok frequency. I mean, this is the one that you hear as if it is true lah. So the source frequency, this is the actual frequency produced by the source F. So you have basically want to find FA from F if you have some motion. So you can see that over here you have velocity there. Okay, and one thing that you have to notice here is the sign here. You have plus minus and minus plus there. Okay, the velocity there, you have three different velocity. You have V, VO, and Vs. V here is speed of sound. It's a constant value, like if you discuss from previous one, maybe about 330 meter per second. You don't have to memorize, you just have to use the one that is given. V0 is speed of observer, and Vs is basically speed of source. Okay, so basically if you have a case of like maybe ambulance and a person, so I just take this example over here. I drew it already. So this ambulance actually is the source. So if it is moving, then you have Vs that is moving in that direction. Okay, and this is the person. Okay, if this person is moving in that direction, that means this one is V of the object. Okay, so you have to think back about some logical things that happens every day lah. Like let's say if you are stuck in traffic jam, and then you have ambulance coming towards you, maybe in opposite direction, on the opposite side, which is not jam, and then you can hear as the ambulance is moving towards you, actually you hear the frequency of the source higher. That means it is actually higher pitch, a little bit nyaring. So you have to differentiate between high intensity of the sound, like you can hear it louder as it comes closer, but at the same time it is actually have higher pitch, higher frequency, and as it is moving away, and then you have a lower pitch. Okay, those are the logical situation. Okay, you can think about it, and then I think you can see clearly lah. So the easiest way to use this formula is that if you have a situation like the ambulance coming towards you, or you are running towards the ambulance, so basically you want to use this one because you have apparent frequency that is higher than the actual frequency produced by the source. Okay, and then if you have a situation where the apparent frequency, or the one that you hear, is lower, like the ambulance is moving away or you are running away from the source, then you have to use the bottom there. Change the color to make it more obvious. So in this case, F apparent is less than the source frequency. So whenever you get the situation or from the question, you have to think a little bit. Is it producing higher pitch or lower pitch? Okay, higher frequency means you have to use the top one, so plus and minus. If lower frequency, you have to use the bottom one. negative and plus there. Okay, so we go through example after this, but before that I would like to discuss some situation. Okay, for example, in this case, you have maybe you are eating nasi lemak at mamak there, and then you have ambulance. I mean, maybe you have some accident over here, injured person there. So this ambulance is actually coming towards that person to, rawat there. So the velocity of the ambulance is in this direction. So this is source velocity, and as it comes closer, you can actually hear the apparent frequency higher, like FA is bigger than F, right? In this case, the V observer is equals to 0 because you are not moving. I mean, you are eating, so you are sitting. So maybe Vs, I just put a number like 30 is to be, I think, maybe 10 meter per second, example. Okay, so if you want to apply the formula just now, if you want to apply this formula, okay, you have to think a little bit about this case. Like, the ambulance is coming towards you, you should hear higher frequency, so you should use the top one over here. Okay, just copy this one first. And V0 is equals to 0, so that one is equals to 0. Vs have a number, V is 330, and then F here is the source produced by this one, okay, by the ambulance itself. Okay, and then let's say, and then after that the ambulance now already passed you, and then still going towards the person there. Okay, in this case, the ambulance is actually moving away from you, right? So if you want to apply this formula, you have to think a little bit. So if, let's say, the ambulance is now moving away from you, the source is moving away, so you will expect apparent frequency to be less than the actual one. Okay, so you should use the bottom one, this one. Okay, again, V0 still 0. Just paste this one in advance. Now I just want to copy this back. So this is an example when the observer is not moving, right? And then you have two situations, the ambulance coming towards you and when the ambulance is actually moving away from you. So those situations produce a different frequency. Okay, when it goes, when the ambulance comes closer, you hear higher pitch. When it goes away, you hear lower pitch. So you have to use a different sign convention here. Okay, once you get used to it, it's pretty much simple. Okay, now next part, let's say okay, let's say now the ambulance is stationary. You have medical assistant trying to revive that person, example. So V source is equals to 0. Okay, now you are being like a typical Malaysian. You're running towards the ambulance because you want to see what happened, right? Okay, maybe I just put it like this. Okay, and let's say your V is equals to 2 meter per second. Okay, now you have a situation where the observer running towards the source. So logically, you will hear the frequency higher compared to the actual one. Okay, so if that's the case, you will like to use the top sign convention. Remember that now Vs is equals to 0. You only have VO, observer. And then if once this person get over here, and then maybe he's scared of the blood or something, and this person is running away from the source. Okay, you have the second situation now. Let's put this one as VO, observer. Okay, for the second situation here, plus minus minus plus. Okay, for the second situation, logically, when the person is moving, when the observer is moving away from the source, the apparent frequency will be smaller compared to the actual one. Right. So if that's the case, then you would like to use the bottom one. Okay, and then again, the Vs still equals to 0 because the ambulance or the source is not moving. Okay, I think I pretty much covered situations that they might ask in exam. Okay, one more thing that you might need to know, you might need to use or not, I'm not sure. So you have a graph for this situation, like frequency against this against the position. So if you have an example where the first two example where the ambulance actually coming towards stationary object, and then after that it goes moving away from the stationary object, so you might have to draw something like this. Like this is, I just put a number here. Example, when the ambulance is coming toward the stationary, maybe I can draw it over here. Okay, this is the situation. So V observer is not moving, stationary. The source is moving. As the source is moving towards V0, you will expect that you hear apparent frequency higher than the actual one. Let's say the actual frequency is 500 Hertz. Okay, so when you hear it higher, maybe you hear it at 520 Hertz. So this is the first part. Okay, and then after that, as the source is moving away, you hear it lower. So maybe it's about 480 Hertz. Okay, and to complete the graph, you just draw it like this. Should have some curve over there. Okay, so this is the graph for F against displacement X, position X.